So this is chapter 1C on prime factor decomposition. In this chapter, you'll learn to find the prime factor decomposition of an integer, and 2, you'll find the factors of an integer. So first of all, before we move forward, it's important that you're able to solve the following expressions below. So if you know what to do at this time, go ahead and pause and complete the problems below. Otherwise, if you're not sure, just take a moment here just to watch how I do the first one. So 2 to the power of 3 really means 2 times 2 times 2, because the little 3 in the corner indicates write down 2 3 times for multiplication. Then you have times 3. And then you have 5 to the power of 2, which means 5 times 5, because you're supposed to write down the 5 twice. Then from here, you just multiply it all together. So 2 times 2 times 2 is 8, times 3, times 5, which is 25. And altogether, that should yield you 600. So at this time, pause and go ahead and complete B and C. So 2 times 2 times 3 times 3. This is the same thing as saying 4 times 9, which makes 36. 4 times 4 makes 16, times 3 times 3 times 3 times 3 times 3, which makes 27, and 1 to the power of 100, well, that's just 1. So when you multiply this together, it makes 432. So going to our first skill, finding the prime factor decomposition of an integer. So what we just did there is we actually took the factor decompositions of a number and multiplied together to get the actual number. So if we look back at it, right here, 2 to the power of 3 times 5 to the power of 2, this is a prime factor decomposition because it makes the number 600. So if we look at the skill again, write each number as a product of its prime factors, what we have to do is break these down to its prime factors, not just any factors, it's prime factors. So there's numerous ways to show this, and I'm going to show you 2 ways. First, you can use a tree, a number tree, a factor tree. So if you break apart 150, you can think, oh, what 2 numbers multiply to make 150? 15 times 10. You could have probably done another way, 5 times 30. That's fine. In the end, when you break it apart to its prime factors, it will all be the same. So we continue breaking this apart. 15 is made by multiplying 3 and 5. Those are prime numbers, so I'm going to circle them because that's as far as they can go. Now 10 is 2 times 5, and that's as far as I can go because those are prime. So basically 150 is the same thing as saying 3 times 2 times 5. Now keep in mind there's 2 5s, so I'm going to put a 2 in the corner to indicate there's 2 5s there. Now the other way you can do it is simply by writing it out in a different format. So I see that 150, I can divide this easily by 2. So 150 divided by 2 leaves me with 75. Now I know I can divide 75 by 5, so that will leave me with 15. Now I know I can divide 15 by 5, and that will leave me with 3. Now all these right here are prime factors. So this again gives the same thing as this. So you would write it out as 2 times 3 times 5 to the power of 2. Either way is correct. It doesn't matter which way you do it. Just make a choice, and at this time, pause and do B and C. So let's work it out. 2,100 can be broken apart into 21 times 100. If you break this apart, this is the same thing as 7 and 3. Those are prime. I'm done. 100 can be broken apart into 2 times 50. The 2 is prime, I'm done there. Let's keep breaking apart the 50 into 5 and 10. 5 is prime. And then the 10 is broken apart into 2 times 5. So 2,100 is the same thing as saying 7 times 3 times 2 to the power of 2 times 5 to the power of 2. Now for C, 1,800. I'm going to go ahead and divide this by 2. That leaves me with 900. I will divide this again by 2, and that will leave me with 450. I will divide this by 5, and that will leave me with 90. I'll divide this by 3, it'll leave me with 30. Divide that by 3, that'll leave me with 10. Divide that by 2, it'll leave me with 5. So this is going to be 2 to the power of 1, 2, 3, 2 to the power of 3, times 3 to the power of 2, times 5 to the power of 2. And finally, skill 2, finding the factors of an integer. So in this case, we're not looking for the prime factors, we're looking for all the factors. And there's definitely different ways of doing this. You can do it the long way, you can also do it the short way. If you're wicked and awesome with your multiplication, then you'll think to yourself, oh, I know 1 times 120, 2 times 60, 3 times 40, and you'll keep going until you get all the factors. However, when you start to work with really large numbers, this is not exactly the most efficient way because it really does require that you are able to really think on the spot and find all the factors. Another more efficient way of doing this is simply by breaking it into its prime factors. So let me show you. 120, when we break this down, basically it becomes 3 times 5 times 2 times 2 times 2. So now what we have to do is we have to think of how many different number combinations can we come up with. So I can go with 3 times 5 times 2 times 2 times 2, which means 3 times 40. Okay, so that's one set of factors. I can also do 2 times 3 times 5 and 2 times 2, which means 2 times 60. I can also go 5 times whatever 3 times 2 times 2 times 2 is, which happens to be 24. I can also work with 4 times, because 2 times 2 is 4, 4 times 3 times 5 times 2, which makes 15 times 2, which makes 30. And so basically what you're trying to do is you're trying to make up as many number combinations as possible to get all the factors. So this method requires that you're a very organized person so that you can really make sure that you check off numbers as you go. Now what I have here is not the complete list, there's still more factors to go. So at this time, using whatever method works for you, whether it's to write out a long list of numbers and think about your division skills, or to write out all the prime factors and just make number combinations to get all the factors, at this time, whatever method you choose, go ahead and pause the video and do complete A, B, and C. So if we work it out, here are all the factors that you could have worked out with in any method that you chose. For 120, you have factors of 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24. These are factor pairs, by the way. 6 times 20, 8 times 15, 10 times 12, and that's it for 120. So these are all factored pairs. You can also write them in order: 1, 2, 3, 4, 5, 6, 8, 10, followed by 12, 15, 20, 24, 30, 40, 60, 120. Now for 140, you have the factors of 1, and I'll write it in order, 2, 4, 5, 7, 10, 14, 20, 28, 35, 70, and 140. And finally, for 250, you have factors of 1, 2, 5, 10, 25, 50, 125, and 250. And that's it.